Hello, welcome back to my channel. Today I'll be going over on how to draw Lewis structures, the simple version. So today, with this video, I'm going to talk about simple Lewis structures, and then in the next video, stay tuned, I'll be working on formal charge Lewis structures, and that's a whole other thing. But with Lewis structures, it's basically like a visual drawing on covalent compounds with bonds and lone pairs, so how nonmetals are bonding. And we use valence electrons for bonding, since valence electrons, as you know, or as you should know, the outermost electrons, since they're the most outside, they're the ones doing the bonding. And as a reminder, valence electrons are basically the group numbers, so like 1A, 2A, so group 1 has 1 valence electron, group 2 has 2 valence electrons, so on and so forth up until 8. 8 is the most valence electrons that an element can carry. And when we bond these two nonmetals, it's basically one valence electron to the other valence electrons they are sharing, because covalent compounds, think of the term covalent. Co means together. Think of it as like holding hands, so they're like holding the valence electrons together. Alright, so I'm going to give you an example here. Something very simple. CCl4. Alright, and then we're going to first draw the structural, basically the visual on how the elements are displayed. So C, carbon, is always the central atom. And 99% of the time, whatever element is listed first in the compound is in the central atom. So carbon is in the center, and then I have 4 chlorines. So I'm going to put that surrounding the carbon. So that is my my skeletal structure. And now, before we add the bonds and the electrons, we have to count how many electrons am I working with. And again, with electrons, we're counting valence electrons. We're not looking at, okay, 6 electrons, 17 electrons. No, we're looking at the group number to add them together. So I'm going to put this math to the side here. Carbon is in group 4, as I just showed you, so it has 4 valence electrons. Chlorine is in group 7, so 7 valence electrons. But there's 4 of them, so 7, 7, 7, 7. 7 times 4 is 28. And then we're going to add these together. 4 plus 28 is 32. E minus electrons, so 32 electrons. Now that's a lot of electrons to keep track of whenever we're adding, so I'm going to divide it by 2 so we can work with pairs, because again, covalent compounds, they share pairs of electrons, so might as well kind of make this more manageable by doing 32 divided by 2 equals 16 pairs. So that's a lot better to work with. So I'm going to work with 16 pairs, distributing that in this Lewis structure. So now that I got my math done, now I'm going to work on my structure. So the very first thing you should do is draw your bonds. I'm basically connecting the dots. So line, 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 line. Each line represents 2 electrons. So you can do this if you want, just so it's more visual, better understanding for you. Again, each bond or each line represents 2 electrons. So 1 electron goes to this carbon, 1 electron goes to this chlorine. They're sharing 2 electrons. There's that bond in between. Same thing on this one, this one, this one. So a nice thing about this structure, it is symmetrical. So whatever happens to this chlorine, happens to this chlorine, happens to this chlorine, etc. All right. So I added 4 lines. So I added 4 pairs of electrons. So I'm going to subtract minus 4 pairs. And what I'm doing right now is I'm keeping track of the electrons, so when I get to 0, that means I have added enough pairs of electrons to my structure. So 16 minus 4 is 12 pairs. I have 12 pairs left to work with the structure. So after my bonds, now I'm going to add I'm going to distribute 3 pairs of electrons in each terminal atom. In each terminal chlorine, so the outside chlorines, I'm going to add 3 pairs. So 1 pair, 2 pairs, 3 pairs. So these are lone pairs, meaning these pairs of electrons are not being shared. These are electrons that are only belonging to chlorine, and then this electron here is sharing with carbon. All right, because think about it, chlorine has 7 valence electrons, it wants 7, so when you count the dots, that's why I like to draw these dots here so you can visually see it. You have 1, 2, 3, 4, 5, 6, 7, so it's happy. All right, so I just did 1, 2, 3 pairs, 1, 2, 3 pairs, 1, 2, 3 pairs, 1, 2, 3 pairs. All right, so I just did 3 pairs in 4 chlorines, so 3 times 4 is 12. I used all pairs of electrons, and I'm done. And that's pretty much it. Now, with every structure, whenever it hits to 0, you're pretty much done, but a good way, and I recommend you check your work every single time, is doing the happiness check. And the happiness check is mainly for the central atom, because again, the central atom is like the center of the universe. You can think of it that way. And if the center atom is not happy, the whole structure is not happy. So to do the happiness check, you can do this acronym, VBD, and the V stands for valence, the B stands for bonds, and the D stands for dots. And this is all for the central atom. So we're going to do that. We're going to do that for carbon right now. So for VBD for carbon, and we're going to subtract, by the way. So how many valence electrons does carbon have? We know that it has 4. Minus, and we're subtracting. So 4 minus, how many bonds does it have around carbon? It has also 4. And did I add any dots in the center? I did not, so minus 0. So I know you can see dots here, but the dots come from the bonds. So I have 0 dots around carbon, and then I'm going to do the math here. 4 minus 0 is 0. That means it's happy. So that means I have nothing more to move around, nothing more to add. So when VBD is 0, it's happy. You leave it alone and you're done. All right, so I'm going to give you another example when you need to have dots in the center, actually. So, example, NH3. So first, we're going to look at our structure here. So nitrogen, N is listed first, so that is centered in the middle. And then I put my 3 H's surrounding it. And then we do our math. So when we look at our valence electrons, nitrogen is 5 valence electrons. Hydrogen is in group 1, so 1 valence electron. But there's 3 of them. So 3. So when we add them together, 5 plus 3 is 8 electrons. And then we're going to divide that by 2 to get our pairs. 8 divided by 2, 4 pairs. And now we add our bonds, our lines, 1, 2, 3. We have 3 pairs that we use, so minus 3 pairs. We've got 1 pair left. Alright, so we've got only 1 pair left. And now the thing is, this is why I'm giving you this example, because hydrogen, again, hydrogen does its own thing. It follows its own rules. And you cannot add any dots on hydrogen, because why? Hydrogen has 1 valence electron, and it already has that electron by bonding with another atom. So once hydrogen is bonded, has that 1 electron, you leave it alone. So where does that pair go? If it doesn't go in the outside, you have to put it in the middle. Like that. So this is my structure for NH3. And that makes sense because, again, nitrogen has 5 valence electrons if you count the dots surrounding it. 1, 2, 3, 4, 5. Okay. Now, I just said it's happy, but let's do the VBD check to check its happiness. So VBD for nitrogen. So valence electrons for nitrogen is 5 minus how many bonds have I added to nitrogen? 1, 2, 3 minus, and how many dots have I put on nitrogen? 1, 2. 5 minus 3 minus 2 is 0. Therefore, it is happy, and we are done with this structure. All right. Give you another example. All right, H2O. So hydrogen is listed first. However, again, hydrogen can only have 1 electron, so another special thing about hydrogen is that it has to be on the outside no matter what. So I'm going to put the H's on the outside and then oxygen in the middle, which makes sense because we have 2 hydrogens and only 1 oxygen. The one element that has only has 1 atom of it, it's always in the center. And then now we do our math. Hydrogen has 1. There's 2 of them. Oxygen has 6. And we have a total of 8 electrons. And then you divide that by 2, would be 4 pairs. Now we do our bonds. 1, 2. Minus 2 pairs, we've got 2 pairs left. And again, hydrogen cannot have any dots, so we put these 2 pairs on the oxygen. 1, 2. And we are done. Now let's do the VBD check for oxygen. How many valence electrons does oxygen have? It's in group 6, so 6 valence electrons, minus how many bonds do I have on oxygen? 2, minus how many dots do I have on oxygen? 1, 2, 3, 4. 6 minus 2 minus 4 is 0. So therefore, it is happy. All right, awesome. So I'm going to move on and give you an example of when VBD is not happy and then what to do after that when the central atom has not passed the happiness check. CO2, carbon dioxide. So again, carbon, always in the center. And then the 2 oxygens on the outside. Now we do our math. So carbon has 4, oxygen has 6, and there's 2 of them, so 12. 4 plus 12 is 16. And then we divide it by 2 to get our pairs. 8 pairs. And now we do our bonds. 1, 2. Minus 2 pairs, we've got 6 pairs left. And then we distribute 3 pairs of electrons in each outside atom. Since this is not this is not hydrogen, you can add the dots. 1, 2, 3, 4, 5, 6. Minus 6 pairs, 0. So we are done with the electrons. Now we got to see if we need to move stuff around. And we're going to check the happiness of carbon, the central atom. Right, VBD of carbon. How many valence electrons does carbon have? 4 minus. How many bonds? 2 minus. Do we have any dots surrounding carbon? We don't, so 0. 4 minus 2 minus 0 is 2. And I did plus 2 because since we're subtracting, it may be minus, but for the most part, it becomes positive, so plus 2. So, it is not 0, so that 2 tells us that we need to move 2 pairs of electrons to the central atom, because carbon right now only has 2 electrons, it needs to have 2 more to be happy. So we can't add any more electrons, we need to move stuff around. So what we're going to do is, I'm going to grab a lighter color. I'm going to add this pair over here to make a bond, this pair of electrons to make a bond. So we're making double bonds right now, so that way we still have the correct number of electrons that we just calculated, and we make the central atom happy. So what we end up with is, I'm going to just rewrite the Lewis structure. This is a Lewis structure of carbon dioxide. All right. Awesome. So I'm going to give you 2 more examples of you to try by yourself. I would pause the video, do the work by yourself, and then unpause to check your work. So I'm going to give you 2. So the first example, this should be pretty simple. SO2. And then another example, BrF5. Alright, pause, and then unpause. Alright, these are the Lewis structures that you should have gotten. So with this example, the VBD for sulfur, it is not happy yet, so I have to move 2 pairs for the double bond, and then BrF5. When I did the VBD for bromine, it is happy already, and then when I did the pairs, I had to have an extra pair move on to the center. All right, so that is pretty much it for Lewis structures, a simple version. Thank you so much for watching, and have a great day.